The topic of this video is how do we interpret horizontal and vertical aggregate supply curves.
And the math behind the economics is horizontal and vertical lines.
Okay, we often think of aggregate supply curves as being upward sloping, like the red curve in this graph, and that shows that as prices increase, more goods and services will be supplied. But what if we have an aggregate supply curve that's horizontal? How would we interpret this? Or what if we have an aggregate supply curve that's vertical? How would we interpret this? And note that in all of these diagrams, we're just including an aggregate demand curve so we can identify the equilibrium points.
In order to be able to answer questions such as these, we need to be able to understand horizontal and vertical lines and what their equations are and what their behaviors are. So here is a horizontal line. Notice that along this horizontal line, what do we have? We have the x value is, the y value is always 2. And the x value can be anything. No matter what value for x I plug in, I'll get y equals 2. So the equation of this line would just be y equals 2, and the slope of the line, which remember is rise over run, the slope of the line is going to be 0 because the change in y, while y never changes, so it's going to have a slope of 0. And the equation again is y equals 2. Y is a constant and x is arbitrary. What about for a vertical line? In this case, again, we can have any y value here, but what do we know? We know that x is always equal to 2. For every single point on this line, x is equal to 2, and y can be anything. Well, what would the slope be in this case? Again, when we consider rise over run, well, rise, y is arbitrary, so y is any old value, but run, the change in x is going to be 0. So I would have 0 in the denominator. That's no good. So for this case, the slope is undefined. So for a horizontal line, the slope is 0, and for a vertical line, the slope is undefined, and both can be thought of as constant. In this case, for a vertical line, x is a constant value, y is arbitrary, and in a horizontal line, y is a constant value, and x is arbitrary. So what's true in general? The equation of a vertical line is x equals a for some constant value a, the slope is undefined, and x is a constant. And for a horizontal line, we have that y is some constant value b, the slope is 0, and y is constant, whatever value for b.
Okay, let's use this information with the aggregate supply, aggregate demand diagram. So what if we have a horizontal aggregate supply curve? This tells us that the price value on the vertical axis is going to be constant, and so it's not going to change regardless of what the GDP value is determined by aggregate demand. So if we had shifts in aggregate demand, the equilibrium price would remain constant because of the horizontal aggregate supply curve. Let's look at a vertical aggregate supply curve. So here we see that the GDP value is going to remain constant, again, regardless of the price level. So if we had shifts in aggregate demand here, which would change the price, again, the aggregate or the equilibrium level of GDP would remain constant at that level shown by the vertical aggregate supply curve. So what are some other times that we have horizontal and vertical curves? Some important examples include perfectly elastic and perfectly inelastic demand and supply curves. We have a horizontal demand curve representing a firm in perfect competition, and money supply is often assumed to be vertical.
Now we've seen how to use the math behind the economics to interpret horizontal and vertical aggregate supply curves. Thank you so much for listening.